Hello everyone and welcome to Abaqus FEM. If you're looking to master crack propagation, fracture mechanism, and fatigue analysis in Abaqus, this video is for you. Today, I'm excited to introduce our new Abaqus crack and fatigue analysis package, a comprehensive training course that include here you can see 18 practical workshops based on the real engineering problems. Whether you are a student, researcher, or professional engineer, this package is designed to help you confidently perform advanced fracture and fatigue simulation in Abaqus. Uh, Crack and fatigue failure are responsible for many catastrophic failure in engineering structure. Pressure vessel, bridges, concrete building, aircraft component, pipeline, offshore structure, and even biomechanical implant can all experience crack initiation and propagation during their service life. Understanding how crack uh, grows and predicting when a component may fail is one of the most important skills for finite element engineers. Abacus provides powerful tool for fracture mechanics, but many users find this fracture difficult to learn. These features difficult to learn because practical resources are limited. That's exactly why we developed this package. The package covers four major topics. The first topics, as you can see here, is low cycle fatigue analysis using hysteresis energy. Many engineering components operate under cyclic loading and experience plastic deformation. Traditional stress-based methods are not always sufficient for predicting fatigue life. In this workshop, you learn how hysteresis energy can be used to estimate the fatigue damage more accurately. In the second, the fatigue grows using Paris law. Here you can see. Paris law is one of the most widely used fracture mechanism model for predicting crack growth under cyclic loading. In this package, you'll learn how to calculate a stress intensity factor, define crack growth parameter, simulate fatigue crack propagation in three-dimensional model. These techniques are commonly used in the aerospace, automotive, energy, and structural engineering. In the third section, the XFEM or extended finite element method is explained. One of the biggest challenges in fracture simulation is modeling crack growth without continuously remeshing the model. XFEM solves this problem by allowing cracks to initiate and propagate independently of the mesh. Throughout this package, you learn how to define crack initiation criteria, damage evolution, crack propagation, and how to interpret XFEM results through numerous practical examples involving concrete, timber, pressure vessel, reinforced concrete structure, and many other engineering applications. The fourth topic is fracture mechanics parameter, including the J integral. The J integral is one of the most important concepts in nonlinear fracture mechanism. It is widely used to evaluate fracture toughness and crack driving focus. Our tutor explained not only how to calculate this parameter in Abaqus, but also how to interpret the results. Now let's take a look what it includes in this package. The course contains 18 complete workshops, each focusing on a different engineering application. You'll learn low cycle fatigue based on the hysteresis energy, then famous cult of Winker impact experiments using pre-dynamic crack XFM growth, then fatigue in a steel plate using Paris law, 3D, then 2D. You can define the crack propagation in the reinforced concrete under the cyclic loading, then the crack grows in 5-point bend in the timber beam, in the concrete, reinforced concrete beam, then uh, crack grows in the concrete wall under the normal and transverse load. Then you'll study bone fracture under 3 points bending. You'll simulate fracture in the sustainable concrete containing, as you can see here, this is a bone and this is the, where is that? In the wood concrete cement. And then uh, you will have a J integral model, crack growth in 2D model, then the shear bending in the S-lab, crack definition, and then uh, the crack identification using piezoelectric. This is one of the most important example in this package, using piezoelectric to find the crack location, crack length, and the others. And then seismic analysis of the dams, um, crack growth in pressure vessel, and crack growth in a pressure vessel under variable pressure using deflux, sorry, deload subroutine for the elliptical cracks. And every workshop includes details modeling procedure, geometric creation, material definition, boundary conditions, meshing technical, and all the files. That this package is suitable for mechanical engineers, civil engineers, aerospace, material, biomechanical research and engineers, graduate student, PhD candidates, university researchers, and finite element analysts. Whether you are preparing your thesis, conducting research, solving industrial problem, or improving your professional skills, these tutorials provide practical knowledge that you can immediately apply to your own project. By the end of this training package, you'll be able to confidently model crack initiation, simulate crack propagation, perform fatigue analysis, use XFEM and Paris law, calculate fracture mechanism parameter, interpret engineering result, and solve complex fracture uh, model. Okay, and at the end, each tutorial includes the INP reference paper if available, material definition, and tutorial video. And at the end, we have the payment method. The price for this full package is 127 euros, and we accept PayPal, Visa, MasterCard, and all the cryptocurrencies. Before payment, contact us through this email to tell you more about the payment process, content of the package, or anything that you need to know. For now, thank you for your attention.